The Cafe Conundrum by Diya and Anna Petal. For a quick overview of the problem, we'll begin by addressing the dilemma, solve the problem, declare the winner, and conclude with a recap of the situation. For the dilemma, Luna and May have been summoned to a coffee showdown. Luna challenges May to a coffee competition. Luna thinks she could finish a large cup of coffee at a faster rate than May could finish a medium cup of coffee. Luna drinks her coffee at a rate of 2 fluid ounces per second, while May drinks her coffee at a rate of 0.5 fluid ounces per second. Both cups have an equal diameter of 8 centimeters, however, their height differs. A medium is 14 centimeters and a large is 20 centimeters. The person who sips at a faster rate will ultimately win. Who will win this challenge? To solve the problem, we used the volume formula, pi times radius squared times height, and factored out pi. We then took the derivative with respect to time and applied the product rule to r squared times height by doing left d right plus right d left. We then plugged in the given variables in the problem, which were dv dt, height, and radius, which we got by dividing the diameter in half. We then changed dr dt to 0 as the radius is not changing with respect to time. We then continued to solve algebraically until we got our rate of negative 0.0397 centimeters per second for dh dt, representing the rate at which the height of the coffee declined. We then solved the same problem for May by utilizing different variables. The rate at which she sipped with respect to time was now 0.5. Therefore, we plugged that in for dv dt. We also plugged in 14 for height instead of 20 as May had a medium cup unlike Luna. Once again, we solved algebraically for dh dt, which is the rate at which May's coffee declined with respect to time, and crunched out the rate to be declining at 0.0099 centimeters per second. To reflect on the dilemma, we knew to figure out a precise winner to the coffee conundrum, we had to be as fair as possible. Therefore, solving for the rate of dh dt, the rate at which the height of the coffee declined or the contestant sipped, was an equitable solution. To start, we took the derivative of the formula for the volume of a cylinder as the coffee cups were cylindrical. We then plugged in the variables that were given for each person and divided the given diameter, 8 centimeters, by 2 as the radius was needed. Luna had a rate of 2 fluid ounces per second, which was her dv dt, and her cup was 20 centimeters tall, which was the height. May had a rate of 0.5 fluid ounces per second, which was dv dt, and her cup was 14 centimeters tall, which was also the height. Once all variables were plugged in, we solved algebraically to determine dh dt. May had the more faster rate of negative 0.0099 fluid ounces per second compared to Luna's rate of negative 0.0397 fluid ounces per second, thus representing a faster decline in height and sipping rate. Since May had a faster rate of decline in height of coffee with respect to time, she ultimately won the challenge.
Gelato games featuring the greed of May. May is no longer satisfied with her significant win against Luna. She now wants to develop a record time to chow down a gelato cone. She asks the cafe for a cone only to realize that she is chowing down, her cone is leaking out. The height of the gelato cones at the cafe are 18 centimeters and the diameter is 12 centimeters. The rate at which the ice cream is leaking is 3 centimeters cubed per second. At what rate is the height of the gelato declining when it is 14 centimeters deep? For this problem, we are given dv/dt, which was negative 3 cubic centimeters per second, the diameter of the cone, which was 12 centimeters, the radius, which was 6 centimeters, and the height of the gelato, which was 18 centimeters. The height at which we are finding the rate is 14 centimeters. We are trying to find dh/dt, which is the rate the height of the gelato is decreasing. To solve for dh/dt, we had to use the formula for the volume of a cone. We then took the derivative of the formula and found the radius of the gelato when it was 14 centimeters deep, and we did so by setting up a proportion of the initial radius and height to the new radius and height that we were starting off at. We found the radius to be 4.666 centimeters. The next variable that we needed to solve was dr/dt. In order to find dr/dt, we had to get dr/dt in terms of dh/dt. We found this by setting up another proportion in the initial radius and height and then isolating the r. Now that we know that the radius is equal to 1/3 times height, we can take the derivative of both sides to get dr/dt equals 1/3 dh/dt. Since we have all our missing values, we can plug it into the derivative of the volume formula. We divided 1/3 pi as well as simplifying inside the bracket and dividing out dh/dt. After much simplifying, we get that the rate of the height of the gelato is decreasing at 0.044 centimeters per second. For our reflection, we found the rate at which the height of the gelato was decreasing when it was 14 centimeters deep by finding both dr/dt and the radius at 14 centimeters by setting up proportions. After calculating those variables, we plugged it into the derivative of the volume of a cone and solved, giving us a rate of negative 0.44 centimeters per second. Thank you. The end.